Hello everyone, welcome to solve this nice math problem, which is x to power of x to base 5. This is equal to 625. So what is the value of x? Solution from here, we have that x to power log x to base 5, this is equal to 625, okay? Now, have x to power log x to base 5, this is equal to 625. So for the value of x, we introduce the natural logarithm on both sides so that we'll have log x to power log x to base 5. This is equal to log 625. Okay. Now log x to power log x to base 5. This is in the form of log a to power n, which you can express as n log a. Okay. So applying this property, we'll have log x to base 5 multiplied by log x. This is basically equal to log 625. Okay. Now log x to base 5, this is in the form of log a to base b, which we can express as log a divided by log b. So let's apply this property. So we'll have log x divided by log 5 multiplied by log x. Okay. This is equal to log 625. We have log x times log x. This is log x squared divided by log 5, which is equal to log 625. Okay, so let's proceed. Log x squared divided by log 5, this is equal to log 625. So we multiply both sides by log 5 and also here by log 5. Okay, now 625, we can express 625 basically as 5 to power 4. Okay, so this is the same thing as log x to power 2. This is equal to, now this is log 5 to power 4 multiplied by log 5. Okay, so log 5 to power 4, applying the power rule property, this can be expressed as n log a. So log 5 to power 4 becomes, so this is log x to power 2. This is equal to 4 log 5 by applying this property times log 5. Now we have log x to power 2. This is basically equal to 4 log 5 squared. Log 5 squared. Now, so for log x, we introduce the square root sign on both sides so that here, this is log x, this is equal to plus or minus the square root of 4, okay, log 5 raised to power 2. And that means that log x is equal to plus or minus square root of 4. This is actually 2, okay? This is basically plus or minus 2 log 5, okay? The square root simplified there. So we have log x is equal to plus or minus 2 log 5. So that means that we have the first two values of log x. The first value of log x, this is 2 log 5. And the second value of log x, this is basically negative 2 log 5. Now, let's solve for the values of x, okay? From equation 1, that is for log x equal to 2 log 5, and equation 2, log x equal to negative 2 log 5, as follows. From equation 1, that is log x, which is equal to 2 log 5. We can calculate the value of x by introducing a logarithm identity with base 10. That is 10 to power log x to base 10. This is actually equal to 10 to power 2 log 5 to base 10, okay? So now 10 to power log x to base 10, this is in the form of m to power log a to base m, which is basically equal to a, okay? So applying this identity, that means that 10 log x to base 10, this is equal to x, which is basically equal to, now here we have 10 to power 2 log 5 to power 2, which is basically 10 power log 5 squared to base 10. So that means that this is actually 5 to power 2. So x is equal to 5 squared, which is actually 25. So this is the value, the first value of x. This is the first value of x. So let's solve for the second value of x. Now from equation 2, which is actually log x is equal to negative 2 log 5, introducing this logarithm identity with base 10, we'll have 10 to power log x to base 10. This is basically 10 to power negative 2 log 5 to base 10, okay? So applying this identity, we'll have x is equal to, now this is the same thing as 10 to power log 5 raised to power negative 2, okay? This is 5 raised to power negative 2, which is actually 5 to power negative 2, which is 25 raised to power negative 1. And that means that x2, this is 1 over 25. Now this is the second value of x. So the second value of x is 1 over 25, okay? So let's quickly verify that these values of x actually satisfies the equation by following these steps. Let's verify that the value of x1, which is 25, and x2, which is 1 over 25, actually satisfies the equation. Now, if you recall, we end that x to power log x to base 5, this is supposed to give us a value of 625, okay? Now, from what we have here, we have the value of x as 25, which we can express as 5, okay, to power 2 log 25, okay, to base 5, all right? So this is the same thing as 5 to power log 25 squared, this is the power, to base 5. So applying the property that m to power log a to base m, this is essentially supposed to give us a value of a. Applying this property, that means that 5 to power log 25 to power 2 to base under base 5, this is equal to 25 squared. And 25 squared, this is basically 625, okay? So that proves that x equal to, that proves that x1 equal to 25 actually satisfies the equation. Now for x2, which is basically 1 over 25, okay? Or rather 25 raised to power negative 1. We can prove this as, now we have 25 raised to power negative 1, okay? Log 25, which is raised to power negative 1 under base 5. We can express 25 basically as 5 to power 2, okay? So here we'll have 5 to power negative 2 log 5 to power negative 2 under base 5. This is the same thing as 5 to power log 5 raised to power negative 2 times negative 2, okay? And this is basically equal to 5 raised to power log 5 to power 4 under base 5, okay? So this is what we have here. Now, that means that 5 raised to power log 5 to power 4 under base 5, this is essentially equal to 5 to power 4, applying this logarithm property. And therefore, that means that the solution is 5 to power 4, which is equal to 625. And that proves that x2, which is 1 over 25, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe, my good people. Subscribe, my good people, so that you can be able to see more of my videos.